If you have an electric utility vehicle with lead acid batteries that are low mileage and high maintenance like these, and you've been wondering if you can swap them out for a lithium battery with no maintenance, then this video is for you. Welcome back to Boneset Ranch. Today I'm going to swap out these old lead acid batteries for a new lithium battery that should give me longer distance travel, and it should be maintenance free. Plus, I should be able to track the charge of the lithium battery better than these old lead acid batteries. We picked up our Tracker EV in the spring of 2021. It was COVID, as you can see. It was shiny and new, and then the batteries were fresh and could still last from 5 to 15 miles depending on the terrain. We confidently drove it around our property, and we even took it along with us for a trip to Wyoming a couple of years ago. However, the range of the original lead acid battery bank started to slack in the past year or so, until it finally stopped reliably making the trip to the lower end of our property and back. The decision to make was to replace the existing lead acid batteries for around $2,400 and have them last another 3 years before buying more, or go with a lithium battery solution that can be fully warranted for 5 years with less maintenance for $1,000 or more than the cost of the lead acid batteries. Lead acid batteries at $2,400 for 3 years of service translates to $800 per year in cost. The combined weight of 6 batteries is 510 pounds. By comparison, however, the lithium battery is only 150 pounds for the entire unit. And the lithium pack comes with a full 5-year replacement warranty costing $3,900, which works out to be $780 per year. So the cost per year works out to be the same. The maintenance-free nature of the lithium battery, while enjoying 2 to 3 times the range of the lead acid batteries with no maintenance, tipped the decision to lithium. I chose to purchase a Fleet Lithium 105 amp-hour battery because of the full replacement warranty and the proven installation success in other Tracker EVs. There's a link for Fleet Lithium and other products in the description, such as the installation seen on videos by Life at the Hamptons on another YouTube channel, who also offers the battery as a dealer for the manufacturer. This is what it looks like inside. The outer box is double-walled steel. The battery cells inside are fully welded together and isolated from the protective outer shell. The BMS is sized to fit the high amp demands from the Tracker EV motors. You can see that there's a fan here for cooling, which is more active than the BMS that I have on my little ATV motor. Heavy duty cables, which I can just get a hint of the battery cells here. Each battery is spot welded together as opposed to soldered, so as a unit all the individual cells are not individually serviceable. It'll be fun to stick this inside. Removing the bench seat is an easy first step. Well, what you see here is how bad these batteries have gotten to be. I've cleaned them several times over the past couple years, and they still keep off-gassing and creating the acid that you see here. So they are not holding their charge because they don't have the same seals that they once had. So my first objective is to remove the crossbars here out of the way if I can, and to take off all the battery clamps and all the cables and leave only the positive on this side and the negative connection on that side. And the new battery will sit in this space, and it will only take up as much as this area here as opposed to the entire area. It'll also allow me to install the charger on the unit itself so that all I'll need to recharge it is a extension cord nearby to recharge the buggy. Each lead acid battery weighs 85 pounds and there are no handles and it's too tight to pick them up from under. I had to improvise a way to grab them by the lifting tabs. As you can tell, it's heavy. So there it is, all cleared out. I've removed the batteries. Now, the next step will be to clean this all up and then to install a deck here for the new battery. So here's what it looks like all cleaned up and emptied out. All the batteries are gone. All the wires have been identified. And now I need to build a deck in here. And I also need to get rid of these two posts that stick up from what used to clamp the batteries down. There's a million different ways you could fill it. I happen to have a couple lids from a livestock feeder that are nice sheet metal that I'm going to put down first, and then I'm going to use Trek boards on top of that to fill this gap here and to create a really good barrier for anything that flies up from underneath here so it doesn't poke at the battery box, which will be better protection than the original batteries had. I mean, the bottoms of those batteries were just exposed to the whatever that I threw at them from on the trail, so it'll be nice to have a little bit more protection for the unit. It's a perfect day here to work on the UTV and the safety of the shop. The Cobra chickens, of course, are curious about what we're doing down here. I finished installing down in here today. So I have my negative terminal that needs to go to the negative side of the battery, and I have the positive terminal that needs to go to the positive side, but I also need to be able to hook in line 72 volt to 12 volt converter. To do that, I'm going to install some bus bars so I can both extend the cables and route them exactly where I want and how I want, plus have a place to add any extra electronics like the power that goes from the battery to the converter from 72 volts for 12 volts. I'd like to look at putting a plate that goes across this backside here so that any of the road debris stays outside of the compartment. Let's see if this works. So far, so good. Lights. Don't have a winch yet. Originally, the winch was connected to the #1 battery in the series, where it could draw 12 volts for the full amps it needs to operate. There was a long delay in shipping. Fortunately, Kevin and Paul with Fleet Lithium were wonderful to work with to get the shipment to me after the first shipment was lost in the routing. I can't say enough good things about how well they responded to the challenge that UPS threw at us. All right, after much delay in shipping, the second part of my battery install has arrived. I've got the charger unit, which needs to be mounted on the vehicle itself, a way to plug in the charger unit through the body of the vehicle with a regular extension cord. This is the meter that will show on my dashboard the status of the battery at a glance. The Bluetooth module that will allow my phone to hook up to the battery and check its metrics, and then a power converter that converts the 72 volt power into 12 volt power, 30 amp. If you're replacing your batteries from scratch, it's important to buy this conversion kit to go with the battery. You can buy the battery alone, but that's more of an option if you're going with more than one battery on an installation. But if you're only going a single battery, make sure you buy it as a kit with the additional item. Okay, on the passenger side here, I'm going to install the charger in this former battery spot and hook it into the bus bar. First step was to turn off the battery before use. There's a slight delay after you turn the switch off before the light goes out. That's normal, and it's important to check that the power is off before you do any work. So I pulled the battery as far forward this way as possible to still leave me the room to reach in here and access the bus bars for installing the wires and checking the lug tightness at a different time. I have 2 empty bus bar points here that I can connect the last of my components, which will be the charger and the inverter unit. The dash is a bit tricky to remove. The screws up front are pretty quick and easy to get to, but there's a couple tabs in the back that you have to reach from underneath and relieve the pressure before you can pull it out forward like this. You can see I've added the battery monitor, and it shows that it is putting between 14 and 16 amps into the battery currently, and it's charged up to 3%, so it's got a little bit of a ways to go before it's charged. So I'll just finish putting this thing back together. Okay, so what you can see up underneath here is that I've added the metal protection for the battery, and it is a very solid deck. I have no fears of anything poking through up there. I've routed all the wires from the dash up to the battery compartment that needed to be done, so I'm done working under here finally, which is nice. You can see here that the battery is 100% and draws a little bit when you turn the ignition on. The plug just goes right there and is quickly and easily removed. I put it on the same side of the cart as the original plug just to keep it the same as what I'm used to going to, instead of me suddenly having to go to the other side of the cart. Here's a view from the other side. You can see the winch battery, the main battery, the charger. Okay, so the installation is complete, and just to show you something, when you first activate any power, the gauge will show as on, but the battery does turn itself off after goes into essentially sleep mode after a time of inactive use, so the gauge does go blank. I've left it to charge and there's no sound of the charger running, so it automatically shut off as it was supposed to. And now we're ready to take it out on the road and give it a good old-fashioned test drive. This is a relatively steep part to start with, and then it gets a little less steep. This road needs a little work here. Hopefully it's doing okay. At 97% battery, just continuing to climb on up here. This is some road I cut last year. Okay, let's turn around. And this phone holder needs to be worked on a bit. Into the camp. This is the way into our camp area. At the end of winter here, I cut this road down here in an area we've never accessed before. Still needs a little bit of trimming and smoothing. I think I can take out a little bit of a hump to take out this steep section here. But once you get down in here, it really opens up with the clearing I was able to do. Well, there you have it. I just completed a full apples to apples test against the original batteries. When we tested the batteries, the EV was brand new. We could get up and down the route I just took 5 times. On the 6th time, we were barely making it back up and had to bail on a person and give it some rest and all kinds of things. So 5 times was the comfortable up and down. I've just completed 6 comfortable trips, and the battery is at 79%. That includes an extra little trip I took up my own personal road, but I wanted to do the original easement road as a apples to apples test to the original new lead acid battery. So what that means is I haven't even used a quarter of the battery's capacity, and I've already gone further than I could do brand new on the lead acid. So if you're trying to decide if it's worth the extra bit of money of lithium over lead acid, I mean, that alone is there. So what I've discovered is every time I pulled myself up the hill, I lost about 4% of this battery, and every time I came down the hill, I put another 1% back into it with the regenerative braking. So I was using 3% of battery for one back and forth trip up and down the hill. Overall, I'm extremely pleased with the durability of the charge. I am extremely pleased with the performance of the EV now. With the lithium battery that provides 100% of power, it doesn't lose its power at a gradient like the lead acid does, to where even though you can still make a distance in the lead acid, you're starting to feel the performance really lag at the end point of those batteries. And with this system, I feel 100% of the power 100% of the time. I also think that it is putting more power back into the battery than the lead acid did. I had no way to monitor it before, which is another plus to the system that I purchased through Fleet Lithium, is the monitoring system that I have for the battery, both in the gauge and the Bluetooth app, that lets me see exactly how much performance I'm getting out of the batteries, and I can really know whether or not I'm pushing any limits. My next task for this is to give it a full endurance test. I'm going to use my own personal road that I've cut, which is a little bit steeper than the easement road that was built by the miners back in the gold rush days. My parts of my road are a bit steeper, so it's a little bit more challenging, and we'll see how many miles I can go on truly challenging terrain up and down. I'm looking forward to more adventures, and I'm very pleased to have this EV refreshed and ready to go. Thanks for watching.